everyone. My name is Sanders Kleinfeld, and it's my pleasure to welcome Mark Mattson to Talks at Google today. He's here to discuss his new book, The Intermittent Fasting Revolution, The Science of Optimizing Health and Enhancing Performance, which makes a scientific case for the immense health benefits of increasing the fasting period in between meals. To quote the book, studies in humans have shown that intermittent fasting is effective in enabling weight loss and can improve health indicators in ways that suggest protection against diabetes, cardiovascular disease, and cancers. The brain can also benefit from intermittent fasting by reducing levels of anxiety, improving learning and memory, and protecting against common neurological disorders such as Alzheimer's disease and stroke. Mark Mattson served as the chief of the Laboratory of Neurosciences at the National Institute on Aging and is currently adjunct professor of neuroscience at Johns Hopkins University. His areas of research include the aging of the brain and neurodegenerative diseases, including Alzheimer's and Parkinson's, which he has published on extensively in scientific journals, including Nature, Neuron, and the Journal of Neuroscience. Among the accolades he has received are the Alzheimer's Association Zenith Award, the Metropolitan Life Foundation Medical Research Award, and the Santiago Grisolia Chair Prize. Thank you so much for joining us here today, Mark.
Well, I'm looking forward to talking to you, Sanders.
Great. Let's kick it off. So many of us have been instilled with this belief that a healthy eating pattern entails having breakfast, lunch, and dinner every day. But you throw down the gauntlet right at the beginning of this book and say, a lifestyle characterized by 3 meals plus snacks every day and negligible exercise results in suboptimal brain function and increases the risk of major neurodegenerative and psychiatric disorders. So I was wondering if you could tell us why exactly is a frequent eating pattern so potentially detrimental to our health?
Well, there are several reasons. One of the main reasons is with the current epidemic of obesity, including childhood obesity, is on a background of 3 meals a day plus snacks. And now, particularly recently, but ever since the agricultural revolution about 10,000 years ago, humans have had food available for the most part, at least in industrialized countries. And so when they have food available, they tend to overeat. And prior to then, for example, hunter-gatherer societies tend to eat intermittently depending on the season of the year, what food's available. And the other thing is we don't expend much energy, physical energy anymore, at least a lot of us. And that's very abnormal with regards to our evolutionary history as well.
Yeah. So, I mean, for me, it initially seemed pretty counterintuitive that fasting could be so healthful. But when you think about it from an evolutionary perspective, as you were explaining in your book, it actually makes a lot of sense. I was wondering if you could talk a little bit more about our evolutionary history and how we sort of became programmed to deal with an environment of scarcity.
As a neuroscientist, my main interest is on brain evolution.
Mm-hmm.
And I've made the case in a number of publications that the major driving force, that is the major evolutionary pressure for brain development, was food scarcity. And this is easy to see if you look, for example, at predators in the wild. Wolves, for example, they often go extended time periods without killing prey. And during their evolution, individuals who cooperated with others were successful in getting food because they were able to corner and kill large prey animals that a single wolf couldn't kill. So that's one example where, the social brain or cooperation aspects of the brain evolved as a adaptation to food scarcity. In the case of humans, based on all the archaeological evidence, all the early tools invented by humans were tools that had to do with acquiring and processing food. Stones, arrowheads, bows and arrows, eventually, stones for grinding, breaking nuts, grinding food. And in fact, there's a big literature on evolution of the prefrontal cortex, which is at the front of our brain, and that brain region has increased the most during primate evolution, and particularly human evolution. And it turns out that scientists who have studied primate evolution came to the conclusion that the prefrontal cortex, its main function evolved in decision making, and particularly in what's called foraging decisions. That is, for example, if our arboreal ancestors in the tropical canopy, they would learn where different types of fruit trees, the fruit got ripe at different times of year, and so on, and they'd have to figure out where to do that. So anyway, that's a long-winded saying of there's a lot of intuitive and scientific evidence that suggests that we are adapted, our brains and bodies are adapted to intermittent eating patterns.
Right, and now in contemporary society, all of that cognition that was formerly devoted to locating and securing food is no longer necessary. It's become quite easy for us, and I assume that results in a big disconnect in terms of like how our body reacts to that abundance.
Yes, and there are some data from measuring skull volume, skull size, that prior to 10,000 years ago, before there was agriculture, the overall size of the human brain was about 10% bigger than the brains of modern humans. So this is, we don't know exactly, clearly our brain has been repurposed for more specialized tasks, whereas in the natural environment, we're like moving through the environment, which is a big thing actually. Right now, we don't physically, a lot of people don't physically move through their environment much during the day. And so, yeah, everything working together, sensory motor systems, thinking about what you're doing, remembering where you've been, and then language. Actually, there's a strong case that evolutionary pressure for development of language was food scarcity, overcoming food scarcity.
Right. So, can you talk a little bit about how intermittent fasting can sort of counteract some of those, deleterious effects of modern society and bring us back closer to the way things were many, many, many centuries ago?
There are a number of ways, and there's a lot of data from animal studies and quite a bit from humans, not as much in terms of exactly what's going on in the cells and organ systems in our body and brain. We know from both animal and human studies is that an eating pattern that involves time periods with no energy intake of at least 12 hours or more, and that occurring periodically, so anything longer than say 12 hours, certainly by 16, what's happening is during the first 10 hours after stopping eating, the energy that your body and brain are using is pretty much all coming from your liver in the form of glucose. And then after 10 to 12 hours, that energy store is depleted. Fats are released from your fat cells into your blood, and they're converted to what are called ketones. And this switch from glucose coming from the liver to ketones coming from the fat seems to be an important factor in the health promoting effects of intermittent fasting. The ketones themselves are a good energy source for cells, but also the ketones stimulate a number of processes in cells that help the cells become more resilient. So, for example, one thing that happens with intermittent fasting is there's a process called autophagy, which is essentially it's a garbage disposal and recycling system of the cells. And all cells in your body and nerve cells in your brain, they have this mechanism whereby if a molecule is damaged or if even a big part of the cell is damaged, such as the mitochondria, which is the energy producing part of the cell, this process of autophagy, these damaged molecules or cellular constituents are moved to this garbage disposal recycling system, so the damage is removed. So intermittent fasting stimulates that system. Another mechanism whereby intermittent fasting may protect against a variety of chronic diseases is by reducing inflammation. Tissue inflammation is involved in all sorts of chronic diseases, arthritis for sure, but also cardiovascular disease where there's inflammation of the blood vessels. Even in the brain, in Alzheimer's disease, there's local inflammation occurring in the brain. Another mechanism in the brain is that the intermittent fasting increases the production of a nerve cell growth factor. That's a protein that, as its name implies, promotes the growth and also stress resistance of nerve cells. Yeah, so those are some of the ways.
Yeah, that's really amazing. So in the book, in addition to all that, you cite several studies that show a correlation between intermittent fasting and longevity as well. And I was wondering if you could talk a little bit about how intermittent fasting could potentially slow the aging process.
A lot of the data here is from animals.
Hmm.
Studies have shown that if one takes rats or mice when they're young adults and puts them on every other day fasting regimen throughout their adult life, they live up to 50% longer than do control animals that have food available all the time. So essentially, we're comparing hunter-gatherers to modern day people with refrigerators and fast food drive-throughs. And the reason I point that out is because a lot of the animal studies, including many of mine, the control group is always animals that have food available all the time. And also they're relatively sedentary. They're in small cages and typically don't have running wheels. So we're taking couch potatoes and we're putting them on intermittent fasting eating pattern. And we see it can extend their lifespan dramatically. It can suppress age-related cancers. It can protect the brain against dysfunction and degeneration of nerve cells in experimental models of Alzheimer's disease, Parkinson's disease. And moreover, if we maintain rats or mice on intermittent fasting and then we subject them to an experimental stroke where we transiently shut the blood supply off to part of the brain, the animals on intermittent fasting show less brain damage and they have less impaired function.
Wow. Have there been sort of analogous studies that have been done in people, like longitudinal studies that I assume are probably in progress?
Yeah, the issue with longitudinal studies is so lifespan studies in humans are virtually impossible, right? You'd have to
Hmm.
start with a lot of people at a younger age and then follow them for 50 years or whatever. What has been done is there are some shorter term studies, a year, some more now, with intermittent fasting. And what's looked at is biomarkers of aging or indicators of risk for age-related diseases. So these involve a lot of blood work. So for example, looking at oxidative damage to proteins and fats. So by oxidative damage, I mean damage caused by free radicals. So if you take blood sample, you can essentially look at an indicator of free radical damage to molecules. That's reduced with intermittent fasting in humans. Inflammation, I mentioned. Also, there have been some studies taking muscle biopsy and showing that are providing evidence that the intermittent fasting bolsters mitochondrial resilience and actually increases the number of mitochondria in muscle cells. We think this is also true in brain cells and we've shown this in animals on intermittent fasting. Over time, it takes like several weeks to a month for us to see this. We see increased number of healthy mitochondria in nerve cells. That means the nerve cells, essentially, they have a better energy reserve.
Yeah. Wow. So I've got to admit, as I was reading your book, I was thinking all this seems a little too good to be true, and I was wondering if there are any downsides or risks to an intermittent fasting habit that people should be aware of. Any circumstances when it's actually not a good idea to do intermittent fasting?
If someone already has a very, very low body weight that's getting to the unhealthy level, based on body mass index, it doesn't make sense for them to do intermittent fasting. Although I should say there have been studies showing that in normal weight people, they can maintain and build muscle mass, through resistance training as well when they're on intermittent fasting as eating breakfast, lunch, dinner. Elderly people in particular with low body weight, because that's a predictor of poor outcomes but often actually their loss of body weight during older age is a sign there may be some underlying disease. Very young children that are in the exponential phase of growth. There is some interest, though, in children with obesity, the possibility that changing their eating pattern, if that can help them get their daily calorie intake down so that they can get their weight down. There's actually pediatricians doing studies on that now. Pregnant women, we don't know. And it turns out that as science progresses, views and data and recommendations change. So, for example, it used to be that someone who's had a heart attack, the cardiologist, and this is a long time ago now, 50 years ago, the cardiologist would tell them, you got to take it easy. You don't want to put stress on your heart. But now that's like not the advice given by the cardiologist. It's to get in an exercise routine to help them avoid another heart attack. And same with pregnant women. It used to be the advice was, don't overdo it. Take it easy. Get plenty of energy intake because you got to support the development of your developing baby. But actually now, as long as the woman's a normal body weight, it seems like it's important for them to stay healthy during their pregnancy, and it may not be good for their child, the baby, when it's born, if, for example, they have obesity or type 2 diabetes.
Right. So you sort of alluded to like the conventional medical wisdom sometimes changes, and I was wondering, intermittent fasting specifically represents like a really big paradigm shift in terms of what constitutes healthy eating habits, in contrast to the you must have 3 meals a day sort of orthodoxy that I think a lot of us are familiar with. So I was wondering how your recommendations have been received by the medical community thus far.
Initially, we started this research on intermittent fasting focusing on the brain back in the 1990s in animal studies. And
Hmm.
then in the early 2000s, we got involved with some human studies where essentially we measured a lot of things in blood samples from the studies. And the popularization of intermittent fasting began with a study that Michelle Harvey did in England with our help in women at risk for breast cancer, and they were put on what's now called 5-2 intermittent fasting. So 2 days a week, eat only one moderate sized meal. The other 5 days, eat what you'd normally been eating. And so he published those studies, and a producer for the BBC picked up on it and did a documentary back in 2013. And then that got really hot in the UK, and in the ensuing time, it's kind of pretty quickly gone viral on the internet. But in the meantime, a lot of human studies have been done. And 2 years ago, the New England Journal of Medicine invited me and a colleague to write a review article on the effects of intermittent fasting on health, aging, and disease. And the reason that they invited us to write the article, well, two reasons. One, a lot of physicians are being approached by patients asking them about it, and physicians may not know much about it, and in many cases know hardly anything about the science and the fact that there's a lot of human studies been done already. And yeah, so I think that mainstream medicine now is just in the last few years become more and more aware. There are many, many dozens and dozens of clinical trials of intermittent fasting in humans ongoing, many in cancer patients. There's evidence from animal studies that it's easier to kill cancer cells if the cancer cells are exposed to chemotherapy drugs or radiation when the individual is in a fasted state. And the reason is the cancer cells rely mainly on glucose as an energy source and can't use ketones. So if you hit them with the chemo drugs or the radiation when they're in an energy deprived state, they're easier to kill. Um, and then also many clinical trials ongoing in diseases of inflammation, inflammatory bowel disorders, for example.
That's great. So there are a variety of ways to practice intermittent fasting, as you allude to in your book, and you just alluded to one a minute ago. So you mentioned that two of the most popular intermittent fasting regimens are the 5 and 2 fast that you were talking about, where people eat normally 5 days a week, and then on the other 2 days they restrict their food intake to under 600 calories, and also the daily 16 to 18 fast, where people consume all of their food during a 6 to 8 hour period each day, and then fast the rest of the day. And I was wondering, is there any particular intermittent fasting method that you recommend people use? Are some approaches more advantageous than others when doing this?
In terms of head to head comparisons with regards to health improvements, unfortunately, there have not been head to head studies in the same study comparing daily time restricted eating to 5-2. For example, either of those shows benefits compared to 3 meals a day plus snacks.
Hmm.
From a practical standpoint, from both feedback I've gotten on some of the human studies I've been involved with, it's easier for people to adopt a daily time restricted eating approach versus 5-2, for example. That is, just make it part of your daily routine to only eat during, say, a 6 to 8 hour time window each day. And you can arrange that according to your own daily schedule. A lot of people find skipping breakfast is the easiest. They can just get up, go to work. Um, and then the other thing is, from a psychological standpoint, it's fairly easy too, certainly compared to calorie counting diets where people tend to obsess over how many calories they're eating every meal. And that seems to kind of exacerbate the whole problem because they're thinking about food all the time. And there is, in fact, a brain system that through hormones regulates your appetite and so forth, so that the more you eat, the hungrier you tend to get
Yeah.
in the long run. And in fact, people with obesity often feel hungry a lot, even though clearly they have plenty of energy stores. And from a survival standpoint, from an evolutionary standpoint, they don't have to worry. But and we know what's going on. There's something called leptin resistance. There's a hormone that when you eat, it's released into the blood, goes to your brain and tells you you've eaten enough, stop eating. And the brain doesn't respond to this hormone, which is called leptin, in people with obesity. Um, and also, I should point out that leptin, the sensitivity of your brain to leptin is improved by intermittent fasting.
Cool. So it can counteract that sort of problematic feedback loop then.
Yeah, yeah.
Yeah. So I think for a lot of people, perhaps some watching this video, adopting an eating pattern that includes long periods of fasting and calorie restriction might seem daunting. So I was wondering if you had any advice or tips for how to successfully sustain this sort of lifestyle of intermittent fasting.
The most important tip is that for people initiating the change in their eating pattern, it will take several weeks to a month or so before they completely adapt psychologically, and their brain hormone systems adapt so that they're no longer hungry and irritable and maybe can't concentrate well during the time period they had previously been eating. So, for example, I've had many people uh, approach me and say, I can't do, I was going to try and skip breakfast. I can't do it because if I skip breakfast, I'm hungry and irritable, hangry, or whatever you want to call it. And, they just, and I say, yes, it takes a while so that you'll no longer be hungry in the morning. And kind of a typical time period is 2 weeks to a month. So that's kind of the number one tip.
Hmm.
You have to stick with it for at least that long for these initial, if you will, side effects to disappear. That's similar to exercise. If you've been sedentary and you go and try to run 5 miles, you're not going to feel very good. And you're going to say, I don't want to exercise it. I don't feel good. But, if you kind of build up to it, and that's another thing people can do with the daily time restricted eating. They could kind of, over a period of a few months, progressively narrow the time window they eat each day. But anyway, just like with exercise, it takes time to adapt to intermittent fasting.
So go at it gradually and don't give up would be two big
Yeah,
pieces of advice. Yeah.
yeah.
Cool. Also, in the book, you talked a little bit about devices and tools that people could use to track their progress during intermittent fasting. So things like breath meters and ketone strips. I was wondering if that would be something that you would recommend for people who are doing intermittent fasting as a way to track their progress, and if so, like how frequently they should do that sort of thing.
The ketones, I don't think they have to track those. If they go 12 hours or more without eating, the ketones will be going up by about then. One thing I didn't mention is, and this would apply to people who exercise in the morning before they eat. If you exercise, say after 10 hours of overnight sleeping, that will accelerate the onset of the elevation in ketones and accentuate the increase in ketones. So the combination, so exercise during the fasting period will kind of give a boost to all these mechanisms I talked about. They're activated by the fasting. And yeah, was there another part to that, or does that answer your question?
Yeah, I think that was the main question, which is basically we should trust that if we're fasting for more than 12 hours, it's
Yeah.
working. We don't need like actual proof from
And
like
then
some digital output. Yeah.
in the long, what I would suggest is in the long term or over a period of a few months, look at your resting heart rate. Often resting heart rate will go down. Not immediately, but by a month, by 2 months or so. And if you want to, you could have your doctor have some blood drawn before you start on intermittent fasting, and then a month later or 2 months later, and just kind of the normal thing, glucose. I would suggest insulin too. So low insulin is generally a good thing. It means your body is able to respond to insulin very well and remove the glucose from the blood. And then also hemoglobin A1C is another one along those lines.
That's great. That's great. I also wanted to point out that I think in the book you make a real effort to contextualize intermittent fasting as one of three pillars that are really critical to good health. So the others being physical exercise and intellectual stimulation. So I was wondering if you had recommendations on additional habits beyond just intermittent fasting in terms of exercise and brain health that we should sort of integrate into our daily routines.
Well, as far as diet composition, I'm sort of along the lines of eat plenty of vegetable, eat at the lower end of the food pyramid, but avoid simple sugars and um, my own opinion is complex carbs like in beans and nuts are not so much, but whole grains is okay.
Mm.
Um, I'm not so keen on the ketogenic diets per se, unless they have plenty of vegetables. And it turns out that, and this is a whole nother discussion, but I did touch on this in one of the chapters on diet composition in the book. Turns out that the emerging evidence suggests that the chemicals in vegetables and fruits that are good for our health, the reason they're in those plants from an evolutionary perspective is to keep insects and other organisms, including us, from eating too much of those uh, plants, and particularly the vital parts of the plant. So, for a quick example, chemicals in fruits that are good for our health are generally located in the skin.
Mm-hmm.
So that's the outer part where insects would feed first. We did study with collaboration with a group that identified a chemical that's at high levels in the skin of green tomatoes. And then as the tomatoes ripen, the amount of that chemical in the skin goes way down. So I don't know if you've ever tried to eat a raw green tomato, but they're extremely bitter taste, and that's because of this chemical. And at that stage, the seeds aren't fully formed in the tomato. But then when it gets ripe, we eat the tomato, then we poop out the seeds,
Yeah.
and that's an evolutionary thing for them. But we found this chemical in the green tomato skins does some good things to nerve cells in the brain. We published a paper on that.
Yeah, I think in your book you also mentioned caffeine is extremely beneficial in the same way in terms of stressing the cells.
Yes, and caffeine, if you were to take pure caffeine and put on your tongue, it has a very, very bitter taste. And actually, it's part of the bitter taste of tea and coffee. And so again, these bitter tasting chemicals that are in the plants to keep us from eating too much of them are actually good for us. During evolution, we evolved several ways we can consume these and them not have bad effects and actually have good effects on us.
That's really good to know. So we have a lot of questions from the audience. So I'd like to kick off the audience Q&A. Pull up the first question. So a question from Mark. Can you speak to the alterations to the performance of your metacognition from fasting and what this might say about the evolutionary roots of metacognition?
I wish I could, Mark. We need human studies looking at rigorously looking at cognition in humans. They haven't been done. We partially completed a study at NIA before I retired, and the neurologist who was heading the studies he hasn't finished it up because of COVID, actually. So we took older people, ages of 55 to 70, who had obesity, and we put them on either intermittent fasting or control, which is just advice for healthy eating, and let them go for 2 months and did a battery of cognitive tests, test executive function, other kinds of cognitive domains. We did functional magnetic resonance imaging, are doing, of their brain to look at neural network activity. And we also did spinal taps. We can take the fluid that bathes the brain and measure different chemicals that we found change with intermittent fasting in animals. But those are the kinds of studies that need to be done. And so far, except for the one that we're not done yet with, I'm not aware of any. So, I think those are really good studies, and they could actually just be done with, good cognitive testing and just use that as the endpoint without anything else. So I think, for example, if Google wanted to do that study with Google employees, they could do it. And one way to do it is like, you have people that haven't been doing intermittent fasting, you do their cognitive test, then you put them on intermittent fasting for a few months, do the test again. Then you have them go back to their previous eating pattern and do it a third time. And you could get a lot of data. The thing is, you need a lot of data for these kinds of studies because there's a lot of inter-individual variability in performance on some of these tests, and even day-to-day variability and time of day variability. So you need a big N, and Google has a big N.
Cool. We'll stay tuned for more research in this area. Do we have any more questions? A question from Vimal. Do you recommend 24-hour or longer fasts? And if it's for general health, not to lose weight, how often would you suggest them?
Yeah, I think that can be done. There haven't been too many human studies at all done with that. And once a week, twice a week, if you've got a nice healthy body mass index. If you're an exerciser or an athlete, and in order to maintain your ideal weight, you're going to have to make up for those calories lost over, say, the other 5 days if you do this 2 days a week. But scales are cheap. You can weigh yourself, but it's actually it wouldn't be hard to do, actually, to make up those calories if you just do it 1 day a week or even 2 days a week.
Cool. Another question. Maddie asks, how should women approach intermittent fasting given that some research has shown it to be less effective for women?
Yeah, the research is a little mixed on that. I think the research in women with obesity, if they can change their eating pattern and stick with it, and particularly if their overall calorie intake, over weeks and months is reduced. There are studies, for example, I just got interviewed recently, and this is kind of anecdotal, unfortunately, but there's a lot of intermittent fasting forums and, for example, magazines and so on, and people are kind of semi-scientifically following women and how they do changing to intermittent fasting versus, say, Weight Watchers or something like that. And it looks good in those sort of anecdotal type things. Now, women, of course, young women, adolescents, there is a problem with anorexia nervosa, which is a psychiatric disorder. It's a kind of an obsessive compulsive disorder. And there'd be certainly concern there. There have been no studies on that, but you wouldn't think it's a good idea for them to go to intermittent fasting eating pattern.
Well, do we have another question? Stefan, what do you believe is the ideal fasting length, and do you support full day fasts? For example, once a week. We sort of answered this. Do you have any more to add on this one?
Well, we answered the second part, and I think earlier when in my conversation with you, I think 16, 18 hours a day, if you're going to do daily time restricted eating, is good. Some people even constrict their time window more to like 4 hours, but personally, I find that kind of hard to get enough calories without, feeling uncomfortable.
Yeah.
Yeah.
Cool. Another question. David asks, what is considered breaking a fast? So supplements, coffee, anything with calories, etc.
Anything with calories.
So does that include coffee or not include coffee?
No,
I'm
well,
assuming just
no,
black.
coffee, black coffee does not have calories. Tea doesn't have calories, but if you put sugar and cream, it does. So.
Cool. Another question. Heather asks, if we think of fasting as a function of calorie reduction, duration, and cadence, what is the best fast for human longevity? For example, 100% calorie reduction, water only for 3 days every month.
We don't know. We really don't know. And again, particularly in overweight people, 3 days a month, if, over a period of time that enables them to get their weight down, that's great. I should say that there have been studies, we've published a number of studies in animals, but also in humans, suggesting that there are some benefits of intermittent fasting, health benefits, that go beyond what can be accounted for by reduction in calorie intake. In fact, in the studies we did with Michelle Harvey in England, our control group, we matched them so that their calorie intake over a period of months was reduced the same amount as the women on 5-2 intermittent fasting, and yet we saw more loss of belly fat and better improvement in glucose regulation in the women on the intermittent fasting compared to, say, Weight Watchers type, counting calories each meal.
So the timing really does have additional effects beyond just the calorie restriction. So it
Yes.
really does matter when you eat.
Right.
Yeah.
Yeah.
Next question. Swapnil asks, can someone with diabetes do intermittent fasting safely?
Type 2 diabetes, yes. Type 1 diabetes, no. So most common type of diabetes is related to age and being overweight, and that's called type 2. It's when you develop insulin resistance. Your pancreas is putting out a lot of insulin into the blood, but your cells don't respond to the insulin, and so your cells don't take up the glucose from the blood, and your blood sugar is high. Type 1 is insulin deficiency diabetes. Your pancreas is not producing insulin. So those people have to take insulin or they'll die of hypoglycemia. And, so type 2 diabetes, any patients should consult their physician. There are some studies now showing that people with type 2 diabetes can benefit from intermittent fasting. Type 1, there's been no studies, and one would have to be very careful how one approach that in consultation with the doctor. And, if you're going to, because probably what would happen is if you did do intermittent fasting, you would require a little less insulin, and you'd be more prone to hypoglycemia when you take the insulin. So it'll be a little tricky in controlling the blood sugar there.
Good to know. Good to know. Next question. Mahesh asks, how should someone do a longer fast, more than 24 hours, if they have had their gallbladder removed?
I can't answer that question. That's, I'm not an expert on, you can live, there's many people, in addition to this listener, probably others who don't have a gallbladder. I can't, off the top of my head, I can't think of a reason why you couldn't do fasting without a gallbladder. But I don't want to give any advice. Consult with your physician.
Next question. Ruoping asks, is simply skipping breakfast considered intermittent fasting? There are some research papers on the supposed ills of skipping breakfast. How should we think about this?
Yeah, a lot of those papers were from quite a while ago. And for example, there were studies done in school-age children, say middle school children or high school, and kids who normally eat breakfast, they'll randomly assign them to either skip breakfast group or eat breakfast as you normally would group. And then that same day, just before noontime, they would evaluate the kids on how well can they focus on their classwork or whatever. There's ways you can kind of quantitatively do this. And the conclusion was that skipping breakfast is bad for kids' cognition. Well, the problem with those studies are the kids weren't adapted to intermittent fasting. So remember, I mentioned that if you normally eat breakfast and then one morning you don't eat breakfast, you're going to feel hungry and irritable, can't concentrate. It takes time to adapt. And many of those studies were funded by the breakfast food industry. And no surprise. But there have been what are called meta-analysis of essentially looking at all studies of effects of breakfast on health. And the conclusions of those, the best meta-studies is that there's really no evidence that breakfast is critical for good health. And in fact, there's some evidence that in certain scenarios, it may not be good. In particular, the current epidemic of obesity is on that background. And there's also, we can get into science, but there's a lot of problems with what are called epidemiological studies, where you just look at thousands of people, you ask them, do you eat breakfast or not? And then they say, oh, there's a correlation between whether this person ate breakfast and whether they had obesity. Okay, and some people will jump to the conclusion, oh, if you don't eat breakfast, that causes obesity. But and this has been a big problem with biomedical science and communication to the general public. And you'll see a headline. The headline will be, skipping breakfast causes obesity. Well, the problem with that is that kind of study doesn't establish cause effect. There are so many other factors in a person's life besides whether they or not they eat breakfast that might influence whether they get obesity. Okay. Like, are they eating fast food? And so on and so on. So anyway, overall, my conclusion from studying the literature is that skipping breakfast is not an unhealthy thing to do.
Good to know. Good to know. Next question. Edwin asks, are there types of food to eat or not eat post-fast?
These short fasts that we've been mostly talking about, daily time restricted eating 5-2, just eat healthy food. Otherwise, no, doesn't matter, except that it should be healthy food.
Do we have another question? Mark asks, does exercise during fasting enable achieving ketosis sooner?
Yes, we answered that previously. The answer is yes.
So you would definitely recommend that if you're exercising and fasting and on a given day, that you should be doing your exercise during a fasting period.
Yeah, that's my opinion. There's a lot of interest in this concept amongst endurance athletes now. And, so in these long events like ultra marathons and so on, kind of used to be that everybody would take glucose on board, Gatorade during the event so that you have enough energy. But we've done some studies in animals that suggest that endurance is better if you do your training in fasted state. So we've trained animals on treadmill for several months when they're either on intermittent fasting or not. And the animals that were on intermittent fasting at the end of a couple months have better endurance on a maximum endurance treadmill test. So I think that kind of the short answer is we don't know 100% sure in humans. But again, if we go back to the evolutionary perspective, our ancestors in the wild had to be able to expend a lot of energy, physical exertion in a food-deprived state. And it makes sense that our brains and bodies are adapted to function well, in that food-deprived state. And all of these mechanisms that evolved are still in our genes and in our cells and organ systems, and we just have to tap into them.
Another question, Aditi. Is it possible to have some weight gain during the intermittent fasting journey before you start losing weight?
Well, yes, if somehow you overeat too much and so that your overall calorie intake over weeks and months is increased for some reason. Also, if you get less exercise, but otherwise, you shouldn't gain weight.
Good to know. Another question. So I think we covered this a little bit. Can you define the fasting period? How long do you fast? I think the answer is, it depends on what works for you. Do you have stuff to add?
Well, it has to be at least 12 to 16 hours. 16 hours for sure
Mm-hmm.
will be enough to get this metabolic switch, which we think is so important in setting in motion these uh, processes in cells that make them more resilient. And then we covered how long you fast.
Another question from David. Does intermittent fasting have to be sustained over an extended period to be useful? How often can you cheat and still reap benefits? For example, one non-intermittent fasting day a week.
I would again make the analogy to exercise. You know, if you've been exercising regularly for 5 years and then for whatever reason you can't exercise for a month, um, you've gained a lot of benefit over those 5 years. You will get out of shape over that month, but so it's kind of a thing where the longer you can sustain it during your adult life, the better. Um, that's been shown with exercise, probably true with intermittent fasting as well.
Well, another question. Huwu asks, learned that beyond intermittent fasting, limiting animal product intake slows aging. How does these understandings study influence keto diet? So talking a little bit about the types of food you eat, animals versus the keto diet. Or yeah.
Well, Hau, I would answer your question like this. Yes, there's data that high protein intake is bad. And it turns out that most Americans have a high protein intake. And now we're coming back to this, the evolution of the research. So if you take animals, rats or mice, and you put them on a diet with low protein, they live longer. No change in calories, just low protein. What's happening is the low protein, we can get most of the protein we need through even a vegetarian diet. Okay. And certainly there's many animals that are vegetarians that do fine. So there's protein in foods other than meat. And what's happening, it gets a little complicated, but there's a pathway in cells, a mechanism of cells that stimulates them into a growth mode. So when you take in a lot of amino acids from the proteins in your diet, it stimulates these cells to go into a growth mode. At the same time, the garbage disposal recycling system shuts down. So if you're constantly in a cell growth mode, that's a bad thing. So the switching back and forth between stress resistance, conserve resources mode during the fasting or exercise, and growth and what we call plasticity resilience mode during eating, resting, sleeping. So these, cycling back and forth between the mild challenge of the fasting or exercise and the recovery period is what seems to be good for optimizing health.
Great to know. So I think we're just about at time. So thanks everybody for the great questions. And thank you, Mark, as well for joining us. And be sure to pick up Mark Mattson's new book, The Intermittent Fasting Revolution, wherever books are sold. And thank you again for joining us, Mark.
Thanks, Sanders. It was a pleasure talking to you.
Yeah, it was a great conversation.